What is up, Longhorns? And today we are going to go over tangent lines with a circle. So, a couple things we'll need to know before we get started. So we need to know what a tangent line is. So a tangent line, or a tangent to a circle, is a line in the plane of the circle that intersects the circle in exactly one point. So if we look, we have where it intersects, where it's getting pointed to between A and B, where it intersects. And then the point where a circle and the tangent intersect is the point of tangency. And so the point of tangency now, so we would have ray BA is a tangent ray, and then we would have just segment or line BA is a tangent segment. So we can have part of it where it's just A and going, or from B and going out to A, or we could have the full segment. But the biggest thing is that line is going to be on the outside of the circle. So the big thing here is outside of the circle, and it's going to intersect at one point on the circle. So with a tangent line, the first theorem we're going to have is if a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So if we look, we have this line AB that is running this way. And so what it's saying, it's tangent to the center of O at P. So we have this piece here. So if it's tangent, we now have that AB is perpendicular to OP. So notice we have that right angle. We have that, for instance, the angle OPA equals 90 degrees. And then we'd also have angle OPB equals 90 degrees. So it's always going to form a right angle if it is a tangent. So that's one thing we need to know. The next thing is that if a line in the plane of a circle is perpendicular to a radius at its endpoints on the circle, then the line is tangent to the circle. So again, we have AB is perpendicular to OP at P. So what it's saying is right there, that's why we have that right angle marked. So if there's that right angle, it now lets me know that this line AB is perpendicular to the center of O. Whoops. Center of O. And the last one is if two tangent segments to a circle share a common endpoint outside the circle, then the two segments are congruent. So we have BA here, and then we have BC are tangent to O, meaning they are perpendicular to O. So if that's the case and they meet where they're meeting here at B, it lets me know that BA is equal to BC. So for instance, and we can draw it with angle markings, that AB is the same as that. So for instance, if I knew that AB equaled 5, well, BC would also equal 5. So that's just an example with a number. So now we're going to get into a couple of examples actually applying these theorems and how we'll see them. So the first one is ML and MN are tangent to center O. What is the value of X? So I'm trying to find this angle. So if we recall, a shape with four sides will equal 360. Because I know that ML and MN are tangent, that means I have a right angle. So if I add all my angles together, it will equal 360. So I know that angle L plus angle O plus angle N plus angle M will equal 360. So now I'm just going to substitute my values. L is 90 plus 117 plus 90, and then plus x will equal 360. And so now when I solve for x, I'll end up with x equals 63. And so, for instance, the measure of angle M equals 63. So that's one way we can see it. The next way we can see it is we got a right triangle now. So remember, with right triangles, we can use Pythagorean theorem. So the a squared plus b squared equals c squared. So we need to find the radius. And right now the radius is x. So I have BC, which is my radius. So the smallest side, remember, will be A, medium is B, and my long side is C. So we're going to substitute my values in. So I know that A will be x squared plus 12 squared, and that will equal, now here this might be new to us, A to C, this entire distance is x and 8. So what I'm going to have to do is I'm going to have to add them together so that it's x plus 8 and then squared. And so one common mistake we're going to have is how we solve or multiply out this x plus 8 squared. What this really means is that I have x plus 8 written twice. And so we have that favorite word that is FOIL, our other favorite F word, that's FOIL. And so we're going to need to use FOIL as we solve this. So I'm going to simplify this left side. So x squared stays x squared plus 12 squared is 144. And so now we're going to use FOIL. So when I use FOIL, end up with x squared because I multiply the first. The outside gives me 8x. My inside terms give me 8x again. And then I'll have plus 64. And so if I simplify, we'll have x squared plus 16x plus 64. And so now we're going to solve. So I'm going to subtract x squared on both sides, and I'm going to subtract 64 on both sides. So the x squared cancels. 144 minus 64 leaves me 80. Here x squared cancels, and now I'm left with equals 116x, and my 64 is canceled. So now that I have 16x, we'll divide by 16, and I'm left with x equals 5. And so if we wanted to, I would now know that BC equals 5. We already knew that BA equals 12, and now all of AC will be 8 plus 5, which is 13. So now I've found the radius and also the side lengths of the triangle, or right triangle. And the last one. So point O, or center O, is inscribed in triangle ABC. What is the perimeter of ABC? So if we remember from our rules, I know that if they come to make a point, that those 2 points where they meet at A are the same distance. So from A to F is also 10. So if F to C is 8, and I'll do it in a different color. If FC is 8, I also know that CE is 8. And so if DB is 15, I also know that EB is 15. So the entire length of AB is 25. The entire length of AC is 18. The entire length of CB is 23. So to find the perimeter, we're just going to add them all together. So we'll have 25 plus 18 plus 23, and we will get 66 centimeters. So that is it. If you have any questions, let your teacher know.